I was taking a look at the inThinking website, which is splendid, and this item written by Tim Gary caught my attention. The idea that you've got a parabola and you've got 2 points here, and these points are defined by a constant horizontal distance, in this case I think h, and that whatever you do to this point here, the area stays the same. So that was quite a nice idea, so I thought I'd explore that and see how Autograph manages it. So this is what I've set up. I've got y equals ax squared here, and this point here is at a point b, and this value of x is b, and this point here is a value of x of b plus h. So if we vary b, you can see what's happening. It's moving around like that. The constant distance here is h, and the area is staying exactly the same. So how did this diagram get created? Let's start it from scratch. So we start with a new page. Close that down, and we'll enter y equals axx to get x squared. And there it goes. So we'll just pull this down a tiny bit. So now I want to put a point on the graph, enter point on curve at x equals b. Now b, all the constants start off in Autograph with 1, so we can just move that down so we are putting it in a slightly better position. So let's move that down to, say, -1, that will do, or thereabouts. Now the next point we're going to put on is enter point on curve is b plus h. Now h will be 1 again, so it's going to be 1 along from there, which is down there, but again we can extend h to make it a bit more like what we want. So let's put it up there somewhere. That'll do. Okay, then to make this a little bit easier to see, I thought I'd put a vertical line through there and a vertical line through here. And then to show that h is constant, I thought we'd put a point here and a horizontal line and a point holding down Control to see where that intersection is. Bang. So now if we select that and this and right click, do a line segment, and then deselect everything, select the green line and hide it. Right, so there's h, and you can see that as we move b around, let's do that, you can see that h is constant. So okay, now what we want to do is put a line through here, so we select that and this and right click straight line. Now the way Autograph works out areas between two functions is to put a point on the top function and a point on the bottom function, and then we'll sort out where these points actually are in a moment. So deselect, select the top one and then the bottom one. It will give you the area between this and that. So right click, find area, it's off the bottom. We can do the object menu, it might just squeeze in. There we are, find area. Okay, I'm going to use Simpson's rule because I want an exact answer, and just to make the thing a little bit tidier, I have 15 divisions. So there's our area, and all we've got to do now to finish this off is to double click on that and say, well, instead of that being at -1.4, I want that at b. And then this one, double click, I want this one to be at b plus h. Fantastic. Then finally I just select that and right click, text box, area, and that pops over there. So now you can see that whatever we do to b, the area is unchanged. But obviously if we change a, we've got a different situation each time. Sorry, that's not a, that is a. And the area will change this time, of course, because it's a function of a. And if we change h, obviously it changes again as well.